Imagine waking up one morning to discover that the world's largest ocean has quietly been storing enough heat to influence weather across nearly every continent on Earth. No explosions, no towering waves, and no dramatic warning signs visible from space. Just an invisible shift beneath the Pacific Ocean that could reshape rainfall, fuel devastating droughts, intensify floods, and push global temperatures to levels humanity has never experienced before. While most people associate climate disasters with hurricanes, wildfires, or melting glaciers, few realize that one of the most powerful forces affecting our planet begins thousands of kilometers away beneath calm ocean waters. Scientists have been watching this silent transformation with increasing concern, because the Pacific Ocean is once again showing signs that its natural rhythm may be preparing for another dramatic swing. The question is not simply whether El Niño will return. The real question is how powerful it could become in a world that is already warmer than at any point in modern human history. To understand why researchers are paying such close attention, we first need to understand how this remarkable climate engine actually works. Stretching across almost 1/3 of Earth's surface, the Pacific Ocean is far more than an enormous body of water. It functions like the planet's largest heat battery, constantly absorbing, storing, and redistributing energy from the sun. Every day, sunlight pours enormous amounts of heat into tropical waters near the equator. Under normal conditions, strong trade winds blow steadily from east to west, pushing warm surface water away from the western coast of South America toward Indonesia and Australia. This movement creates a fascinating imbalance. As warm water piles up in the western Pacific, colder, nutrient-rich water rises from the deep ocean near South America to replace it. This process, known as upwelling, cools the eastern Pacific while supporting one of the richest marine ecosystems on Earth. Millions of fish, seabirds, and marine mammals depend on these nutrient-rich waters for survival. Farmers, fishermen, shipping industries, and even local economies have unknowingly relied on this natural system for centuries. But nature rarely remains perfectly balanced forever. Every few years, something unusual begins to happen. The trade winds weaken. Sometimes they slow only slightly. Other times they almost disappear entirely. Without those powerful winds pushing warm water westward, the enormous pool of tropical heat begins drifting back toward the central and eastern Pacific. Ocean temperatures gradually rise above average. Atmospheric pressure patterns begin shifting, and weather systems around the globe start responding. This phenomenon is known as El Niño. Although the temperature increase may appear surprisingly small, sometimes only 1 or 2 degrees Celsius, it occurs across millions of square kilometers of ocean. That tiny increase represents an unimaginable amount of stored energy being released into Earth's atmosphere. It is the difference between slightly warming a cup of coffee and slightly warming an entire ocean basin. The atmosphere responds immediately because warm water evaporates faster, producing more moisture, changing air pressure, altering wind patterns, and redirecting jet streams that influence weather thousands of kilometers away. Places accustomed to heavy rainfall may suddenly experience drought. Regions that normally remain dry may receive catastrophic floods. Some countries benefit from favorable growing conditions, while others face severe crop failures. Entire ecosystems can shift within months. Coral reefs bleach under prolonged heat stress. Fisheries collapse as marine species migrate into cooler waters. Forests become more vulnerable to wildfire, and billions of people begin experiencing the consequences without ever seeing the invisible force responsible. What makes El Niño so fascinating is that it is not a modern invention. It did not appear because of factories, automobiles, or fossil fuels. Long before human civilization built cities or burned coal, the Pacific Ocean was already oscillating between warmer and cooler phases. Scientists have discovered evidence of these cycles preserved inside ancient coral skeletons, ocean sediments, cave formations, and even tree rings dating back thousands of years. Nature has been performing this rhythm for millennia. Yet today's situation is fundamentally different from anything experienced in the distant past. Imagine placing the same candle inside two different rooms. One room is comfortably cool, while the other is already unbearably hot. The candle itself has not changed, but its effect becomes far more dangerous inside the overheated environment. That is exactly what concerns climate scientists today. El Niño remains the same natural process it has always been, but it now develops on a planet that has accumulated decades of additional greenhouse warming. Oceans are storing more heat than ever before. Global average temperatures continue breaking records. Sea surface temperatures across many regions have reached levels once considered almost impossible. Under these conditions, even a typical El Niño may produce consequences far beyond historical expectations. This distinction is essential because it separates natural climate variability from long-term climate change. One does not replace the other. Instead, they interact, amplifying each other's effects in complex ways that researchers continue studying every year. During previous powerful El Niño events, the world witnessed severe drought across Australia and Indonesia, while parts of South America experienced intense rainfall and flooding. California often received unusually wet winters. Fisheries along the coast of Peru suffered dramatic declines as cold, nutrient-rich water disappeared beneath expanding layers of warm ocean water. Tropical coral reefs experienced widespread bleaching. Global temperatures temporarily surged, with several El Niño years becoming the warmest ever recorded at the time. Agricultural production declined across vulnerable regions, increasing food prices and placing enormous pressure on communities already struggling with poverty and water shortages. Economic losses reached hundreds of billions of dollars globally, affecting transportation, agriculture, insurance, infrastructure, tourism, and healthcare. Yet despite all these consequences, El Niño itself eventually faded. Trade winds strengthened again, cooler waters returned, and the Pacific slowly shifted back toward neutral conditions or even into its opposite phase known as La Niña. This natural oscillation has repeated itself many times throughout recorded history, reminding scientists that Earth's climate system behaves less like a machine operating at constant speed and more like a giant living heartbeat that continuously expands and contracts. The challenge today is that every heartbeat now occurs against a warmer background than the one before. That subtle difference may determine whether future climate events remain manageable disruptions or evolve into unprecedented global emergencies. If you enjoyed learning something new today, don't forget to subscribe to the channel for more fascinating stories behind the everyday objects we often take for granted. Until next time, stay curious and keep asking why and why not.